All right, lesson 2.7 is about graphing inequalities, which is again going to be something review from Algebra 1. The key here is that when we're talking about equations, we're talking about single points being our solutions. What makes two equations true is where they cross in a single point. What's going to make inequalities true is not a single point, but rather half of the graph. So this is where we're going to be doing our shading. But just again for review, remember greater than and less than are going to be dashed lines, and less than or equal to, greater than or equal to are solid lines. Now I will teach you both methods of knowing which way to solve. You can use whichever method you want. So the first thing we have to do when faced with x minus 2y is less than 4 is we need to get it into that graphing y equals mx plus b with the inequality. So this is what we need it to look like in order to graph, because we need our slope and we need our y-intercept. So the first thing I'm going to do is I'm going to subtract x from both sides. And now I need to divide by -2. And remember, when you divide by a negative, and you're going to divide both pieces, and I always circle that so I remember to flip it, y is going to be greater than 1/2 x plus -2. So now I know that my slope is 1/2 and my intercept is -2. So I'm going to plot my intercept, and my slope is up 1, right 2, up 1, right 2, down 1, left 2, because it's positive. Now I have a less than or equal to, so that means I'm going to have a dashed line, and so my line is going to come through like this. Now this is where I have to figure out, does this top half of the graph here make it true, or does this bottom half of the graph make it true? Half of it will make it true or not. My method is that I pick a test point, and I'm going to always try to pick 0, 0. So I'm going to test with 0, 0. If 0, 0 makes this inequality true, everything above the line will make it true. Everything on the side, including 0, 0, will make it true. If 0, 0 makes it false, everything on the other side will make it true automatically. So what I'm going to do is I'm going to take my original equation. Is that going to be less than 4? Is 0 less than 4? And that is true, so that means that every single point on this side will make it true. And you just go ahead and shade that part of things. Now, the other way you can do this, and this makes me nervous, but this is how the other math teachers teach it, is if you have your y on the left, so you have y greater than something, or y greater than or equal to something, then you shade above the line. If you have y less than or y less than or equal to some number or expression, then you shade below. So you can see in this case we had a greater than, y greater than, so we were in the greater than, so we shaded above. Both methods work. Choose whichever one makes the most sense and you consistently get them right. So the next example, the SAT has two parts. One tutoring company advertises that it specializes in helping a student who has a combined score in the SAT that is 900 or less. Keywords, combined, 900 or less. Remember, is your equal. So basically, if we're thinking about it right now, whatever their verbal score is plus their math score has to be less than or equal to 900. And we've already set up our verbal as being our y and our math being our x. Okay, so write an inequality to describe the combined score of students who are prospective tutoring clients. I did that right here. Okay, graph this inequality. Now, the verbal is our y-axis. So that's what we're going to solve for and treat like our y. So I need to subtract m from both sides. So v is less than or equal to negative m plus 900. So that means that our slope is negative 1 over 1, and our y-intercept is 900. Now, if they have a score of 900 on the verbal, they'd have to have a 0 on the math. And if they had a score of 900 on the math, to get tutoring, they would have to score a 0 on the verbal. That's kind of common sense, and if you think about the x and y intercepts, if you let v equal 0 or let m equal 0, that's what's going to happen. So my line, less than or equal to, actually shoots right down there. Because this is a point for a point. If I score 899 on my verbal, I can only get 1 point on my math, and so we can connect the dots. Now, this is an inequality, and I could test again. Is 0, 0 less than 900? Yes. But common sense should also tell you that it's these scores underneath, because we're looking for something lower than in combination. So that's our boundary, everything below. There's no negative quadrants out here because it doesn't make sense to get a negative answer, a negative score. So we're only talking positive answers. Now, what can we do with a graph like this? With a graph like this, we can answer a question like C. Does a student with a verbal score of 480 and a math score of 410 fit the tutoring company's guidelines? Now, some of you are just going to say, well, 480 and 410 is an 890. Yes. That works because it's less than. But if we go over to our graph and we find that point, which is 410, 480, it actually represents, because remember it's math, verbal. And if we go to 410, which would be about right here, and we go to 480, which would be about right here, and we see where those scores intersect, we can see that they intersect right here, and that is still below and in the shaded region, so that student would qualify for tutoring. We can also graph absolute value inequalities, and they're going to work the same way. So we're going to graph our absolute value like normal, and then we're going to see if we shade inside the V or outside the V. So let's set up a table to figure out what our values are. So our x and our y. So if I put 0 in, I get 0 minus 2, which is negative 2, which is 2. If I put negative 2 in, I get negative 2 minus 2, which is negative 4, which is positive 4. If I put 0, if I put 2 in, I've got 2 minus 2, which is 0. 0 doesn't have an absolute value. Let's do negative 1. Negative 1 minus 2, negative 3. Absolute value is positive 3. Let's do one more positive. Let's do 4. Absolute value of 4 minus 2 is 2. So the answer is 2. So let's go over to our graph. It's a less than or equal to, so I know I have a solid line. When x is 0, y is 2. When x is negative 2, y is 4. When x was positive 2, y was 0. When x was negative 1, y is 3. When x is 4, y is 2. So I can see my v emerging. And now I have to see again, do I shade inside or out? So my method of testing a point, I'm going to test with 0, 0. And so I need to know is, test with 0, 0, is 0 less than or equal to the absolute value of 0 minus 2. So I insert 0, 0 for x and y. So is 0 less than or equal to the absolute value of -2, or greater than or equal to, excuse me. Is 0 greater than or equal to 2? That's false. So that means that 0, 0 is false, so everything on this side is false. So my answer is everything on the inside of the V. And the greater than shade above, shade in, and the less than shade below, shade outside, still holds true. So that's a nice quick lesson for 2-7. Good luck on your homework.